Excel has hundreds of functions, and if you've ever searched for a formula to solve a problem, you know how easy it is to fall down a rabbit hole of trying to remember which function does what. Sum, SUMIFs, COUNTIFs, XLOOKUP, text, if. The list just keeps going. But here's the interesting thing. Most reporting formulas rely on the same small group of functions over and over again. So here's the challenge. If you could choose only 5 Excel functions to use along with your FinSight formulas, which ones would give you the most flexibility? In fact, these functions can do the work of more than 40 commonly used Excel functions, which makes them incredibly powerful tools when you're building reports. The 5 functions we're going to look at can handle a surprisingly wide range of tasks. Things like retrieving data, applying logic, calculating totals, formatting results for reports, and even cleaning up messy text values. When you're building formulas in Excel, most calculations usually come down to things like summing values, averaging data, or counting records. And typically that means using functions like sum, average, or count. But once you start working with filtered data or more complex reports, those basic functions can start to fall short. That's where the aggregate function comes in. Aggregate is a multi-purpose function that can perform many different types of calculations using a single formula. Instead of switching between different functions, you can use aggregate to simply tell it what type of calculation you want. So whether you need a sum, an average, or a count, aggregate can handle all of those. Here's the basic structure. The function number tells Excel what calculation to perform. The options control what to ignore, and the array is your data range. Now you might be thinking, Excel already has a function designed for summing data with filtering, and that's subtotal. And that's true, but subtotal has some limitations. With subtotal, you actually have 2 common options for summing data. Subtotal 9 will include manual hidden rows, but ignore rows that are filtered out. Subtotal 109 will ignore both manually hidden rows and filtered rows. So depending on which version you use, you're always excluding something. That means your totals can change depending on how the data is filtered or displayed. Aggregate gives you more flexibility. Instead of being locked into one behavior, you can control exactly what gets included or ignored. And with financial statements, this becomes really important. All the FinSight templates are set up to use aggregate at subtotals and grand totals. Aggregate is used so that totals remain consistent and accurate regardless of how users interact with the reports. For example, navigating the grouping hides and shows rows, but the totals remain the same. And because aggregate can ignore other aggregate calculations, it also prevents issues like double counting on grand totals. So let's take a look at how these functions behave. Right now we have a simple data set with sales by category and region. At the bottom, we're calculating totals using 3 different approaches. First, subtotal with the function number of 9 that will include manually hidden rows, but it will ignore rows that are filtered out. A subtotal with the function number of 109 will ignore both manually hidden rows and filter rows. And our third will be an aggregate. Start by typing =aggregate and double-click on the word aggregate or use the Alt and down arrow to access the drop-down menu. This will show you a list of all the different calculations that you can do. You'll notice that sum is 9, similar to subtotal. So I'll type 9 and then comma, and now a new list appears showing the filtering options. Now you can choose what to ignore. I will choose 0 to ignore nested subtotals and any other aggregate functions. Then I'll type a comma and select the array and hit enter. That will give us the sum. At the moment, all 3 are returning the same total. I'm going to filter this list to show only bikes. Now, when we look at the totals, here's what we see. Subtotal 9 changed to exclude the hidden rows. Subtotal 109 also changed, but aggregate stays the same. This is the key difference. Subtotal is reacting to the filter and excluding rows. Aggregate, the way we've set it up here, still includes all rows, even the ones that are filtered out. In a simple Excel sheet, this might not seem like a big deal, but in a financials FinSight report, this behavior is critical. Because filtering doesn't always mean you want to exclude data from your totals. Sometimes you're just changing what's visible, not what should be calculated. Now, let's take it one step further. I'm going to manually hide a row. Now look at the totals again. Subtotal 9 still includes manually hidden rows, but subtotal 109 now excludes hidden rows. And aggregate continues to show everything. So again, aggregate gives us consistent results, and this is exactly why aggregate is used in the Finsight templates. There's one more important detail. We mentioned earlier that aggregate can ignore other aggregate calculations, which is really important when you're working with things like subtotals, section totals, and grand totals. Without that, you could end up double counting values. This is also why in Finsight we always use aggregate for summing vertical calculations. Functions like sum will include everything in the range, including other subtotals or aggregate results, which can lead to inflated totals. Aggregate solves that problem. In fact, you can aggregate an entire column even if that column contains other aggregate formulas, and it will still only sum up the actual data values, not the calculated totals. That makes it much easier and more reliable when you're building reports. For horizontal calculations across rows, sum is still perfectly fine to use. But when you're working down a column, especially in a report with multiple levels of totals, aggregate helps ensure your numbers stay accurate. So while aggregate can replace functions like sum, average, and count, its real strength is how it handles filtered and hidden data. And that's exactly why it's the standard function used in Finsight templates. When it comes to retrieving data in Excel, most people immediately think of functions like VLOOKUP or XLOOKUP. And those work well, especially when you're trying to return a single value. But what happens when you need more than one result, or when your criteria becomes more complex? That's where the filter function becomes incredibly powerful. Filter allows you to return all rows that meet a specific condition. Instead of returning just one match like the traditional lookup, filter can return multiple results at once. Here's the basic structure. The array is the data you want to return. The include argument is the condition that determines which rows to keep. So let's start with a common scenario. I have a list of customers and I want to return contact information based on a selected customer name. Up here, I've entered Rocky Ridge Outfitters as my lookup value. First, let's look at the traditional approach of using XLOOKUP. This formula is looking up the customer name and returning the contact and phone number. And it works, but we only get one result. Even though that this customer appears multiple times in the data set, XLOOKUP only returns the first match. Now, let's create the same type of lookup using filter. I start by typing equal filter and double-click. Next, I select the array of data to return, type a comma, then select the include array, and make it equal to our filter value. And here's the difference. Instead of one result, we got every matching record. So now we can see all contacts associated with that customer. That makes filter much more flexible when you're working with real-world data. Filter also allows you to apply logical conditions directly inside the formula. For example, you might want to return a value based on a range, like finding a bonus amount based on a sales tier. So here we have the same sales data set, and we are introducing a bonus tier table. Traditionally, this is something you might solve using nested if statements. So you'd check if sales are less than or equal to 800, return trail pass. If not, check the next range, and continue stacking if statements. And that works, but it can get complicated pretty quickly. Instead, we can use filter. First, we select the array of the values we want to return, pressing F4 to make it absolute to that range. So in this case, we're returning the bonus column, but next, the include statement will have some logic. We're checking for two conditions. Each will be defined in parentheses. Sales is greater than or equal to the minimum range, pressing F4 to make that range absolute, then type asterisk, and sales is less than or equal to the maximum, again making that range absolute. The asterisk acts as an AND condition, meaning both must be true. And when both are true, filter returns the matching bonus. Now let's change one of the sales amounts, and you can see the bonus updates instantly. No nested ifs, no complicated logic, just one clean formula. So what makes the filter so useful? It combines the functionality of several different types of formulas, including lookups, logical tests, and even some conditional calculations. Instead of writing multiple formulas, you can often solve the problem in a singular filter function. And in Finsight, this can become especially valuable. You can do things like returning all transactions for a specific segment like customer, or filter data for a customized view. Filter makes that possible without complex formulas. At some point, most reports need to move beyond individual records and start summarizing data. That's where tools like pivot tables usually come in. They're great for quickly creating summary reports, but they also come with some limitations. They're not always dynamic, and they're not always easy to integrate directly into formulas. That's where the PIVOTBY function comes in. Instead of inserting a pivot table, you can build the same type of summary directly on your sheet and have it update automatically. It combines several of Excel's features into one, including grouping data, creating unique lists, and performing calculations all in a single formula. Here's the basic structure. Rows define what goes down the side, columns define what goes across the top, values are what you want to calculate, and the function defines how to summarize, like sum. Why not use just pivot tables? Pivot tables are powerful, but they're more of a manual tool. They require manual setup and need to be refreshed to reflect updated data, which can lead to reports getting out of sync. Because of this, they are less flexible and harder to maintain in environments like Finsight, where automation and consistency are key. Here we have a simple data set showing store sales by category, location, and sales rep. What we'd like to do is create a summary report that shows categories down the side, locations across the top, and total sales in the middle. Start by typing =pivot and double-click. Use your mouse to select the category as our rows and then type a comma, then select the location as our columns and type a comma, and then select the sales as our values and type a comma, and then type sum as the calculation or select it from the list and press enter. As soon as we enter the formula, we get a full summary report. Categories are grouped automatically, locations are listed across the top, and totals are calculated for each combination. Let's do another example, this time by category and sales rep. Start with the =pivotby, select the rows, next select the columns, then the values, and then sum. It's that simple. Now let's change the data. If I update a value or add a new row, you'll see that the PIVOTBY tables automatically update, no refresh needed. That's a big difference from a pivot table. PIVOTBY is formula driven. That means it updates automatically and can be embedded into reports and works seamlessly with other formulas. PIVOTBY combines the functionality of several Excel features into one. It groups data, it can create unique lists, and perform calculations all in a single formula. When you're working with reports, it's not always about calculating values, it's also about how those values are displayed. Dates, numbers, and totals often need to be formatted in a very specific way for reports or dashboards. And while Excel has separate functions for things like month or year, there's one function that can handle it all in one place, and that function is text. The text function allows you to convert a value into a formatted text result. That means you can control exactly how the numbers and dates appear. Here's the basic structure. The value is your number or date, and the format text defines how it should be displayed. Let's start with dates. Here's a simple data set with dates and sales values. Right now, everything is displayed in a default format. Instead of using separate functions like month or year, you can use text to extract and format parts of the date. So start by typing =text and double-click the function. Next, select the date cell and type a comma. Then type the format. In this example, I'm going to type a single M surrounded in quotation marks, and this returns the month number, then press enter. So let's take a closer look at the formatting of the text function. For dates, M represents the month, D represents the day, and Y represents the year. The number of letters you use determines how that value is displayed. For example, you can see the different variations of each format here. And in column P, those formats are combined to create a more specific customized output. You can also format time values in a similar way, where H represents hours, M represents minutes, and S represents seconds. Just be careful because M is used for both months and minutes, so the results depends on whether you're working with a date or a time value. So with one function, you can handle multiple types of dates and time formatting. Text also works really well with numbers, so let's look at the sales values. These are large numbers which can be hard to read in a report. Using text, we can format them into thousands or millions. So instead of showing 1,250,000, we can display something like 1.3 million. So start by typing equal text and double-click it to select. Select the cell you want to reference, then type quote, and then $0.0 as the format. Next, for each comma you type, the value will be divided by 1,000. So 1 comma produces 1,250, and 2 commas produces 1.3 for millions. Now, if we want to add a literal character like K for thousands or M for millions inside the format, you have to escape it with extra quotes. These extra quotes are just Excel's way of saying, this is text I want to display. But if that feels messy, you can always add the K or the M outside of the formula using a concatenation. So now, instead of showing a long number, you can display something much more readable. In Finsight, this becomes really valuable when you're building dashboards, report headers, or labels and summaries, because often the goal isn't just to calculate a value, it's to present it clearly. Text can replace several other functions like month, year, and day, and even some custom formatting steps. But more importantly, it gives you full control over how values appear. One of the most common challenges when working with data is cleaning it up. You might have names, emails, or text strings where you only need part of the information. And traditionally, solving that requires multiple functions like left, right, find, text before, or trim. But there's a much more powerful option. That's the REGEXEXTRACT function. REGEXEXTRACT allows you to pull specific patterns of text out of a larger string. Instead of telling Excel where to look, you tell it what to look for. Here's the basic structure. The text is your original value. The pattern defines what you want to extract. Now, the pattern part might look a little unfamiliar. It uses something called regular expressions, or regex. But the good news is you don't need to memorize it. You can use tools like AI to generate the pattern for you. Let's walk through a few examples so you can see how this works in practice. Let's start by extracting the first name. Type equals REGEXEXTRACT, select the cell to point to the full name. Then I'm using a pattern that tells Excel to return everything from the beginning of the text up through the first space. And now we have just the first names. Now let's extract the last name. This pattern looks for everything after the final spaces in the text. And again, we get exactly what we need with a single formula. Now let's pull out the domain from the email address. This pattern looks for everything after the @ symbol. And just like that, we get Gmail, Company, and Yahoo. This is something that would normally take multiple steps, but REGEXEXTRACT does it in one. Here's another example. We have an address, and we only want the 5-digit zip code. REGEXEXTRACT can identify that pattern and return just the numbers. This pattern looks for exactly 5 digits anywhere in the text. So even though the zip code is embedded in the address, we can pull it out cleanly. And it can even be used to clean up text, like removing extra spaces. This pattern removes extra spaces from the beginning and the end of a value. So it's not just extracting, it's also helping standardize your data. The key takeaway here is that you don't need to master regex. You just need to understand what it can do and use tools to help generate the patterns. So while it may look a little different at first, REGEXEXTRACT is one of the most powerful tools you can use for cleaning and transforming data. By focusing on just 5 powerful functions, aggregate, filter, PIVOTBY, text, and REGEXEXTRACT, you can handle a wide range of reporting tasks with far less complexity. Together, these functions can replace more than 40 commonly used Excel functions, simplifying how you build and maintain formulas.